a rough guesstimate, we're looking at maybe another 9 months before it's 1.0. But again, as IP developers, we cannot wait, and our customers do not want us to wait till it's 1.0 before we start developing because they want to move fast.
On this episode of Embedded Insiders, we dive into the growing advancements in AI and high-performance computing with Lou Trinullo, Senior Director of IP Product Marketing at Rambus. Lou highlights the evolving data center architectures and the increasing demands for high bandwidth, low latency, and robust performance. He also explains how Rambus is staying ahead of the curve with their recently launched PCI Express 7.0 IP portfolio. Next, Rich, Ken, and I discuss innovation and the memory market, focusing on how the push towards lower latency driven by AI and edge processing has led most companies in the industry to prioritize accessibility, speed, and reliability as key solutions. Finally, in our Engineering Heroes segment sponsored by Wind River, we're highlighting Albert Monero and John Sparkman, co-founders of Limitless Solutions, a University of Central Florida-based nonprofit. The two developed bionic prosthetic limbs, custom designed specifically to fit children with limb differences. Hello, everyone, and welcome to the next Embedded Insiders podcast. I'm Associate Editor Tiara Oliver, and I'm joined, as always, with Senior Technology Editor Ken Briota and EVP and Brand Director Rich Nass.
Hey, guys, how you doing? It's sort of funny that I'm in Florida and it's cooler here than where you guys are.
I am not a big fan of being part of this race at all, and I would like to quit if that all possible.
Race being the human race?
That's fine, actually. At this point, it's been so hot and humid here in the Northeast that I find it unacceptable. I live here for cool weather, and I was promised not a swamp.
Okay. And how about you, Tiara? What's the high going to be out there in the desert?
Well, I'm getting exactly what I was promised. So 113 over here.
Cool, 113. Wow.
Wait,
that's hard to even imagine.
I mean, I don't care how dry your heat is. That's rough.
Yeah, I will not be leaving the premises for the rest of the day.
Yeah, the things that I found weird when I have been in Phoenix in the summer, one thing is that they put rags or towels over the door handles so you don't have to touch the door handle because you'd burn your hand.
Oh, God. I don't ever want that to be a concern in my life.
And a second one that I found that was weird, when the police pull over to the side of the road and they know they're going to be there for a little while, they pop their hoods to let the engine cool off.
Oh, wow.
I feel like that, Tiara?
I don't know about that one. I've actually never been pulled over, so fingers crossed I don't have to see that.
Whoa, hold on. Never been pulled over. Never.
So
I hope you're banging on something wood now.
Either you're way more stealthy than most people, or you actually follow the rules. I'm not going to make you say which it is, but congratulations. I do imagine that hood thing would make it difficult to pursue a speeder. Like, you just, at some point, don't you have to get out of the car and put the hood back down?
Very true.
Very true. Very true. So what's the latest, Tiara?
So in this podcast, in a few minutes or so, I will be interviewing Rambus. So they recently unveiled their PCIe 7.0 IP portfolio, specifically for data centers and AI.
That's actually pretty cool. One of the things I find interesting about this with people like Rambus, and I won't single them out, but I'll put them into the bucket of the memory guys. They are always looking for ways to innovate. And it's really hard when you do memory. In this case, it's a controller. It's not the memory itself, but it's pretty hard to innovate. And they actually do a pretty good job finding different ways to put their memory into these various applications.
Oh, yeah. It seems like the current like big mountain that everybody's climbing with memory is latency. Like, they're just trying to make it so that it's more accessible, faster, and more frequently because there's so much of this edge processing and AI pull on memory that I mean that's such a huge challenge. We've got these giant data sets that just come with built in. It takes a while to search it, no matter how good you are.
Yep.
And it's really interesting the different solutions to that challenge that people are finding.
And the fact that these guys have done a controller to is really the solution to the problem that you just described.
Yeah. I've seen other solutions that are more about like, compartmentalization and segmenting the data and searching sort of in those kinds of category ways to streamline, but that's always a compromise, I feel like. You're never at 100% accuracy that way, and everybody wants to get as close to that as they can. There was a cool announcement back on Tuesday from Microchip. They jumped up to 64 bits, mostly for AI applications, and they've made it. They're targeting it towards space because they've talked about radiation resistance and robustness and low latency and stuff for in space applications. Talk about the edge. But I think that's also related to this. It's that the idea of AI making such a heavy load on the memory process that everybody's trying to find a way to either go faster or work smarter.
Very good. I agree completely. And as I said in the beginning, I always talk to the memory guys and I say, what's different? It's just memory, right? And they always come back with an answer. And sometimes it's a real answer, and sometimes it's just a marking positioning. But I think in this case, they've actually done something significant.
Yeah. It's an interesting question about memory because, and the listeners will be well aware by now, if they've been paying any attention, that I'm not an engineer, but the basic construction of memory seems to be changing. Like for the longest time, computer memory was, RAM or ROM, and it was sometimes how you accessed it was changed and the way it was organized was changed. And of course, allocations change, but the actual basic structure seemed to not change very much. And now it seems like we're shifting into more dynamic structures and more flexible systems, physical things. Yeah. I mean, do you think that's not to put predictive hats on, but is that the solution moving forward? Is being adding more physical size and things like that, or where do you think memory is going?
I do think that is the answer, and I'm going to be writing about something in the near future about wearables, memory for wearables. How you have to put a lot of memory into eyeglasses, for example. And the only way to do that is to make them significantly more dense than they are today.
Yeah. I wonder if there's going to be some sort of solid state kind of thing, the way the hard drive became this solid state function rather than a spinning up function in its physicality. If there's going to be that kind of a step forward in form factor for memory that'll be coming down the line, or maybe one of you out there listening is already doing it.
I would think not, but yeah, let's see what people have to say.
Now, here's Lou Ternullo, Senior Director of IP Product Marketing at Rambus, diving into his company's recently launched PCI Express 7.0 IP portfolio.
So yeah, my name is Lou Ternullo. I've been with Rambus now for about a year and a half, and in this industry itself, in the semiconductor industry for a few decades now, and been tracking a lot of things in the industry, high-speed memory interfaces, how they relate to high-performance compute, and now more specifically PCI Express and CXL interfaces, and again, a lot of their demand is in the HPC market, right? So that's how I kind of got pulled into all of this, the connection between the high-speed memory and high-speed interfaces vis-a-vis PCI Express.
Awesome. So seeing as you've, been in the industry for a while, how would you say, interconnects in general have evolved over time, especially when it pertains to like advanced AI and high performance computing applications?
Yeah, that's a really good question, and I actually often think through these things myself to try and understand the trends themselves and where they're going. And so interconnects obviously started in PCI Express in particular, what we're kind of talking about here, in connecting to a CPU in some way, shape, or form. Um, it started by providing the ability for a CPU to get network access using like a network interconnect card. That was kind of the simplest form, and the data rates for PCI starting with 2.5 gig PCI Express, I guess I should say, because Express is the SerDes base, but 2.5 gig. Now we're all the way up to 64 gigatransfers per second with Gen 6, and doubling that to 128. And so as the industry has evolved, more and more add-on or endpoints are being connected to the CPU. So you have SSDs, NIC cards, which are now turning into what's called smart NICs with an embedded data processing unit, a DPU, which are now performing offload. So the CPU is now overloaded, and so there are components which are adding on to provide offload, like a smart NIC or a DPU, essentially manages the network, which can take, up to 20% of the CPU itself. So offloading that gives the CPU more ability to do the core processing that it's intended to do. Again, GPU started for graphics, and anybody out there that's a gamer knows in the PC world, what that is and why there is a separate processing unit to process for graphics. And AI is an evolution beyond that, right? It's what I would call an significantly accelerated and very high performant offload compute. Albeit a lot of it today is using the GPU infrastructure, but it is a very high performance compute engine, and evolving through time, going from I guess what we call Gen 1 now, all the way to Gen 7, the 2.5 gig to 128 is for that interconnect. There's also in the interconnect space, it's more than just connecting a host, which is on the CPU, to the endpoint device like an FSD or a smart NIC or an accelerator. There's a die-to-die, right? And as compute has gone to more parallel computing, if you will, and in the ability to pull in more than one processing unit, you have these die-to-die interconnects. Your audience is probably familiar with what NVIDIA calls NVLink, which is their proprietary GPU to GPU connectivity. AMD has something called Infinity Fabric, and I don't know if your audience has picked up on the most recent press out there. There's a new standard, which is kind of built by a consortium of companies, which they're calling UA Link or Ultra Accelerator Link, which again is kind of leveraging the ability to do more standards-based, if you will, parallel processing with accelerators.
So, speaking of, where the world of interconnects is going and where your company is right now, you recently unveiled your PCIe 7.0 IP portfolio. And it seems like you guys are pretty early in the space as far as this development in the industry. I know you guys are always looking forward and what's next, but what made you guys ready for this? What made now seem like the time to put this out there? And can you kind of give us a brief overview of maybe the architecture of your portfolio, maybe some of its key components?
Sure. So let me address the first question. Why now? Why not later? You can
Yeah.
always. So there's a couple things, and I talked about the evolution and where the industry, I use the word we, but the industry is going in data rate, and how fast AI is driving it. Your audience has probably read a lot about the memory side with HBM and tying it to accelerators, and how fast that's evolving, HBM3 and to HBM4, and PCI Express is the same thing, because on the accelerator, on one side you have a very, very high bandwidth memory, and on the other side you have a PCI Express, and that data rate is it's being demanded by these high performance applications, which is being driven by AI. Now, some of your audience, and I've even read articles myself, which say, well, we're trying to move too fast. The compliance is important, and compliance for Gen 6 is not even up and running, and what about that? So a couple comments about that. One, it takes a long time between when a spec starts to evolve, and when the IP is ready, when the chip is ready, when the chip design is ready, when it's taped out, and you're looking at a 2 to 3 year cycle. So it's a long period of time, and so things have to happen concurrently. We can't do everything serially, and I'm not saying anything new. This has been how engineering has worked in it for a long time. And compliance is important, but I don't think the industry is going to wait, at least the sense I'm getting, for Gen 7 compliance before they start working with Gen 7. So that's one aspect. The other aspect is that when the PCI SIG developed PCI Express, one of the key requirements is backwards compatibility. So you can have, for example, a PCIe Gen 6 endpoint product that is plugged into and working in the Gen 5 slot on a host, right? And I firmly believe Gen 7 will be the same way. Those that are leading the charge to Gen 7 see the demand for the bandwidth, and they're trying to plan. Now, it may very well be that their first products are used in Gen 6 hosts, and then they're future-proofing themselves for when the Gen 7 host device or host products come out, host CPUs come out. But that's kind of why. And I mean, the spec has started, definitely. I mean, it's at a 0.5 release today. Still a rough guesstimate, we're looking at maybe another 9 months before it's 1.0. But again, as IP developers, we cannot wait, and our customers do not want us to wait till it's 1.0 before we start developing, because they want to move fast. So from a product portfolio, from our portfolio, from an architecture perspective, let me try and visually paint the connectivity, if you will, of the PCI interconnect and how it's evolved. So you have the host device, which sits on the CPU, the host PCIe protocol, and then you have an endpoint which connects into it. Now, as I mentioned, historically, you have a PCIe slot on the CPU, and you plug in your endpoint device, a SmartNIC or an SSD or an accelerator, and it communicates. Well, now the industry is looking to what's termed disaggregation, and so they want to spread out the compute. They want to spread out the sources of storage. They don't want to have everything connected to, have to be very connected to one CPU. They want to be able to virtualize. And the trend to disaggregation is also driving the trend in the use of more switching or embedded switching, and the use of more retimers, PCI Express retimers. And so what that allows is your host now can connect to a switch or an embedded switch, and then branch off to multiple endpoints or a retimer. And if your audience has read about the Copper Link, which is a new PCI Express standard, which extends the reach using specialized copper cables, going from server to server or even rack to rack. And Gen 7, the other thing about Gen 7, which I haven't mentioned yet, is there is an aspect to optical interconnect. And what that's going to allow is a much longer reach, stretching the PCIe interconnect much further away than it has historically been. And that one of the main reasons for staying in the PCIe plane or domain, if you will, as opposed to switching up to Ethernet, which is historically what's been used to go from server to server or rack to rack, is the latency. And that's the direction the industry is trying to drive. As I'm seeing it, and Rambus is developing the PCIe controller IP, the embedded switch IP, and the retimer IP. So that's kind of how it fits into that hierarchy of the PCI Express system, I guess I would call it.
So looking at these, different features um, in this solution, the controller and the retimer and switch, and I know you have your Express agent as well. How do these features maybe differ than something you've done in the past, or maybe even what your competitors are bringing to the table today?
Um, good question. And so we're historically, you can look at these as individual components, and then y- you really need to step back and look at it as, okay, how are they working together? How are they enabling our
Yeah,
customers, the market, the industry, and so forth? And you mentioned Express Agent. Thank you for mentioning that. That is one of the components that we believe is significantly differentiating. And we, as a company, stumbled across this. Honestly speaking, we have we license our IP. Our customers use our IP, and we have our application engineers supporting our customers. And you know, just licensing IP and integrating into your chip is not, it's not where it ends, right? You have to tape it out and you have to bring it up in your environment. And in the process of doing that, there's the physical IP side, the PHY link to link connectivity, but then the protocol side as well. And is it communicating properly? Is it linking up at Gen 1, Gen 2 speeds? And is it progressing up through the protocols from Gen 3 to 4 to 5 to 6 and so forth? Is it doing that effectively? And what Express Agent, how it evolved was, well, customers are having problems in bringing up their product. Usually it's what we call it first link up. When you have your silicon and you're connecting it, host to an endpoint or switch to an endpoint, and you want to get communication working, that's referred to as first link up. And a lot of times, there's a lot of settings that have to be put in place, and it takes a long time. And what Express Agent allows our customers to do is to integrate it with their controller and with their SerDes and monitor the protocol stack and the traffic to help them quicker determine, oh, okay, this is, we're having a problem. We're not linking up because, well, the protocol is dropping or it's not passing the right protocol. So it gives them a path to more quickly debug and bring their system up and running. And I think, having all these IPs for that entire what I call PCIe system, as well as the Express Agent, which is adaptable to each of the products, whether it's a retimer, a switch, or the controller. Um, that definitely, I think, helps our customers at least feel more confident in licensing our product, that they're going to be able to get their products to market more quickly.
definitely. And then speaking of, customer security and things like that and what they're looking for, does this new IP portfolio include any maybe advanced security measures? I just feel like we always have to bring that up in today's day and age, and just security features.
Yeah, absolutely. You're really hitting the nail on the head there, and security is becoming, although security in the aspect in PCI Express, it's essentially referred to as IDE, integrity data encryption,
Hmm.
and it was first introduced in PCIe Gen 5, and it's progressing from Gen 5 through 6 and 7. But I'm starting to get customers that are using Gen 4. Some in automotive, because it seems like the automotive guys are maybe a generation behind, are looking for this type of security. And the other thing, so that's basically encrypting and protecting the link between the host and the endpoint. Now the challenge becomes, now I have a switch and a retimer. And so now the host and endpoint aren't directly connected. There's layers in between. And so the SIG came up with what's referred to as another acronym, TDISP. And what that stands for, really long here, Trusted Execution Environment Device Interface Security Protocol. And what that allows the system to do is it basically sends a packet with an encryption key, but it allows it to carry it all the way through to the final endpoint, which before this, ECN, engineering change notice, was implemented, that was not possible. So now you have a host that can send a packet that's encrypted through a switch, through a retimer, or even two retimers to its endpoint, and it's protected along the whole way.
I guess just for my last question, seeing as you guys are leaders in your field, maybe what can we expect from Rambus in the future regarding these advanced IP solutions? Where are you guys headed?
Sure. So obviously, as the specifications continue to evolve, we're going to continue to evolve with it. I mean, we're already talking Gen 7 and dare I say, Gen 8, which presumably will go from 128 to, 256 will be within the next several years. So that's one aspect. The security is still evolving as well. We have a leading edge security IP as well, and we've been cross pollinating between the PCI Express and security teams to try and build better security products. And as the industry continues to evolve, it's kind of like one of those things that you don't know what you don't know. So as security threats get more and more aggressive, the industry start coming up with better ways to do it, and we're going to be keeping up with that. The other aspect I think is incredibly important, especially in the context of how fast things are moving, is interoperability, and how we can help foster that. And today, most of our PCI Express products are implementable in FPGA, albeit maybe not at the maximum data rates, but definitely at the protocol. And what that allows us to do is to get our products out there sooner, get the IP out there sooner to do interoperability testing with compliance suites, with logic analyzers, and as soon as they're available with the server CPUs themselves. And so I think, just as all engineers in all of our industry, we're going to continue to figure out how we can innovate, make a better product for our customers, because it's not just designing to the specification, but it's designing to the application that's using that specification that our customers are looking for.
Now, here's Albert Monero and John Sparkman, co-founders of Limitless Solutions, discussing their journey to developing bionic prosthetic arms.
When you hear the term bionic arm, it's very possible you think of something totally futuristic, or maybe even something robotic like you'd find in a factory. You probably wouldn't think right away of a bionic prosthetic limb designed to fit a child and painted in a variety of bright colors. Well, that's what University of Central Florida-based nonprofit Limitless Solutions does. Limitless Solutions was founded by UCF alumni Albert Monero and John Sparkman in 2014, and has since grown from a kitchen table to a venture working toward FDA approval to make their bionic prosthetics prescription available to patients with limb differences. So, Albert, can you tell us a little bit about yourself? Your background, how you got into biomedical engineering and building bionic prosthetics.
For most of my life, I knew I wanted to be an engineer. I think it started around middle school, and I was so fascinated by aerospace and this idea of someday having a hotel on the moon. And so I got really involved in that and came to the University of Central Florida to study aerospace engineering. And that's where I did my bachelor's, my master's, and my PhD in aerospace and mechanical engineering. And along the way, I got a little distracted by a different project. And while I was finishing everything up on the aerospace side, I really fell in love with this opportunity to do more of the biomedical engineering aspect. For the University of Central Florida, I'm the executive director of the Limitless Solutions program. Limitless Solutions started as a nonprofit at our kitchen table almost 10 years ago. And little by little, we've been building up capacity. We got our first office, and now it has grown into this full research facility that you see here, about 5,000 square feet and over 50 people working together to try to improve the life and the type of devices we can make for children with limb differences. And it started slow, little by little, and together we were working towards that. And along the way, we had some help from another bionics expert on hand, which was Robert Downey Jr., and he was able to give our very first arm recipient a special Iron Man themed bionic arm, and that really was the catalyst to launch us forward. Fast forward a few years later, we were able to turn that side student project into a component of our university to be able to build it into a research program here at UCF so that we could work towards advancing the future of next generation prosthetics. When you get to watch a child try on their bionic arm for the very first time and then walk out these doors towards the playground, into their classrooms, it is like nothing else. We got into engineering because we wanted to be able to help others and to be able to make something that could be useful for them. And for me, being able to build that system of things and with people to be able to drive that forward has been the most incredible feeling.
Now, obviously, prosthetics are nothing new to the world, right? So what were some flaws or parts of generally used designs that you and your team wanted to improve upon with your own designs when you started all of this?
Children have really limited opportunities for advanced prosthetics. They tend to be very expensive and therefore not prescribed. They tend to be too heavy for the children, and they just generally tend to look like doll plastic. And these were all of the different factors that we kind of naively at the kitchen table thought we might be able to change. But little by little, we've been trying to solve each one of those challenges using everything we learned in our engineering backgrounds. And then we brought in people from all different fields to be able to speak to the parts that we don't really cover in aerospace engineering. I think for the children, it's been a real opportunity to give them the confidence and the expression that their prosthetic becomes more than just the sum of the parts, and it becomes a component of their identity, of the expression that they helped design on the bionic arm. And that's what we're really proud of here.
Those are definitely some pretty big challenges to overcome. Can you explain a bit about how you guys went about addressing all of that?
Traditional, like multifunction use prosthetics can be well over $40,000, and we were starting without any budget. So we were trying to find any way that we could do things differently and leverage technologies from different fields. And so, coming from aerospace, we were trying to think about the arm as a little airplane. So you have a fuselage, you have the avionics, electronics. It's got to be very light, otherwise if it's too heavy, it won't fly for the child. And then trying to be able to figure out how to integrate everything into such a tight, small space so that it would really fit for a child as young as 6 years old.
What has working on this whole venture really meant to you, to John, to your team?
There comes a point in every project, especially in college, that you say, is this that really interesting thing I did in school one time, or is this something more? And I think for both John and I, we had that opportunity where it was something we couldn't walk away from until we saw it through. For me and my goals, our goal has been to be able to provide a device to any child that wants one, and being able to do that without any financial burden to those families. And so we've been trying to see this through to support that goal. And that means in the future going towards our FDA submission and being able to see this be a prescription device, but without any financial burden to those families. That's the ultimate goal.
What's been like a really crucial skill you've noticed or developed during the time that you've spent working on all of this?
One of the most important skills I've been working to develop is really being able to listen and be able to really hear the person. When you're going to work with all of these different innovators from different disciplines and different backgrounds, knowing how to bring all that information together so it can be synthesized into the final bionic arm has been a challenge that has to be embraced in order to be successful in such an interdisciplinary environment.
What would you say has been the most exciting part of this for you?
Engineers love to make things, we like to break things, and then really find how we can use them to be a usable solution for anyone else. Being able to work with bionic arms, we get to create that from the ground up. We get to test it, find kind of its limits, and then try to push those limits in a way that then gets to go out into the real world, on the playground, and into the classroom for these bionic kids. And we've just loved every minute of being able to work towards that. Every day we get to come into this facility and work towards these goals. We're trying to build the future. At our university, the opportunities are really endless, and I'm really excited to watch that continue to grow. We're 9 years in, and we feel like we're just starting to hit our stride on being able to create next generation accessibility technology. And what I'm really excited for is seeing how that can continue to transform more lives and that new designs are going to be leaving the lab soon.
Also with us is John Sparkman, the VP and other co-founder of Limitless Solutions, where he also acts as Director of Technology. John, can you tell us a bit about yourself? How did you come into engineering as a career?
When I was growing up, I actually didn't find myself to be an engineer. I wanted to be a farmer because that's what I grew up doing. So when I went to college, I was a history major, and I didn't find it challenging, so I decided to become an engineer.
Can you talk a bit about how Limitless Solutions really came to be? Like, where did this whole venture begin?
My official job is the lead engineer here at Limitless Solutions. And the company came about because Albert was in his car one day and was listening to the radio. And on there, they were talking about this Enable group that makes mechanical prosthetics for children. So he decided to get involved. He set up a small place inside of his lab in order to help kids. And one day, a mother called the university asking about this person that was trying to do this at the university. And they finally got a hold of Albert at some point in time, and she asked, "Hey, can you make my son an arm?" And he went back to his kitchen table, and he got a group of friends together and started making an arm for this child. And I am the lead engineer here, so I do all of the engineering work from mechanical to design to manufacturing to all the electronics. And I organize a team that helps me do all this.
What would you say is the core mission of Limitless Solutions?
So our main goal here at Limitless Solutions is to make disability technology for anyone in need. One of the main things that we focus on is prosthetics for children because they're so hard to get for them. Some of our personal goals here at Limitless Solutions is to give prosthetics to any child in need here in the US and across the world. Some of our other goals is to also be able to make any disability technology for anyone in need.
What have been some challenges you found yourself and your team facing over the years?
Our challenges have changed so many times over the years. In the beginning, we were having trouble with electronics, soldering them together, making sure they worked every time, making sure the device didn't break every time we gave one to a child. Now our challenges are biomedical related, so we're trying to work towards our FDA clearance.
If you had to identify your greatest skill in relation to Limitless Solutions, what would you say?
My most important skill here at Limitless Solutions is management, time management, people management, design management, making sure everything comes together as a cohesive unit. Because without management, there's no structure in the organization.
Can you talk a little bit about what really excites you about being a part of this and what you envision for the future of Limitless Solutions?
One of the most exciting things for me here is that I get to deliver arms to children here in the United States and hopefully one day across the world. The future development of our device is to be able to make it more robust. So when kids are on the playground, they bend the fingers backwards, it still doesn't break. After being on the playground and getting it very dirty, we want to be able to put it in the dishwasher. Right now, all the electronics are exposed, so we can't do that. So that's the future of our device.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.